Welcome to Science by PK. Today, we're going to explore one of the most amazing and game-changing ideas in science, the Theory of Relativity by Albert Einstein. Don't worry, this might sound complicated, but we'll break it down in the simplest ways possible. By the end of the video, you'll know what it is, how it works, and how it shows up in your everyday life. Let's take it slow and simple and make it fun. Let's start with relativity itself. The word relativity. It means how we see things. Depends on our point of view. Imagine you're in a car driving down a highway. To you, feels like the car is still and the world outside is moving backwards. But to someone standing on the road, it's the car that's moving. Both views are correct. They just depend on who's watching. This is the basic idea of relativity. Albert Einstein took this simple idea and asked big questions about the universe. He found that time, space, and even gravity don't behave the way they always thought they did. Instead, they change depending on how fast you're moving and how much gravity is around. The discovery became the theory of relativity, and it's split into two parts: special relativity and general relativity. Let's start with special relativity, which Einstein came up with in 1905. This part of the theory is all about how time and space change. When things move really fast, close to the speed of light, the light is so the fastest thing in the universe, traveling about 186,000 miles per second. That's so fast that light from the sun takes only about 8 minutes to reach Earth. Here's a surprising fact. Time doesn't pass the same for everyone. Imagine you and your friend both have clocks. You stay on Earth, but your friend gets on a spaceship and travels close to the speed of light. When your friend comes back, the clock will show less time has passed than yours. It's like they time traveled into the future, and it has been proven with experiments. Here's an easy example to help understand. Think about riding a fast-moving train and walking in front of the train. You're moving faster than something just sitting on the train. Now imagine if the train is moving close to the speed of light, and you're walking inside it. To someone outside the train, the motion looks slower than it feels to you inside. This difference is how we experience motion. Also affects the time and space. Now let's move to general relativity, which Einstein introduced in 1915. This part of the theory about gravity. Before Einstein, people thought gravity was just a pulling force objects together, like how Earth pulls us down, but Einstein discovered that something even cooler. He said that gravity is actually bending of the space and time. Imagine a space as a giant rubber sheet. If you put a heavy ball on the sheet, it creates a dip. Smaller objects will roll towards the ball because of the dip. That's how gravity works. It blends in space and time. That bending makes things move towards each other. Here's a fun example. Think about the moon orbiting Earth. It's not being pulled by a rope or chain. Instead, the Earth's mass creates a dip in space, and the moon is rolling along that dip. It's like a marble rolling around a bowl. This is why planets orbit stars and why objects fall to the ground. You might wonder, how does this affect me? Well, let's start with something that you use every day, GPS. Your phone uses GPS to figure out where you are, but did you know GPS wouldn't work without Einstein's equations? The satellites that make GPS work are moving around really fast and are far away from Earth. Both special and general relativity affect their clocks. Time moving differently for the satellites than it does for us on the ground. If scientists didn't correct for using relativity, GPS would be better off by miles. Scientists didn't. Another real-life example is the twin paradox. Imagine two twins. One stays on Earth while the other travels to space in a super fast rocket. When the traveling twin comes back, they'll be younger than the twin that stayed on Earth. This isn't just cool science idea. It's something astronauts experience. When they return from space missions, time has passed slightly differently for them compared to people on Earth. Every simple things, like your gold jewelry and glowing neon lights, involve relativity. Gold shines the way it does because of reverstic effects on its atoms, and the neon signs the way particles emit light involves Einstein's ideas. Relativity might sound like it's about a huge space stuff, but it's a part of everyday world. Let's talk about the universe. Black holes, those mysterious places in space, can only understood by general relativity. A black hole, like I mentioned in my couple of videos later, is where gravity is so strong that not even light can escape it. It bends space and time so much that everything near it gets pulled in. Einstein's equations help scientists understand these extreme places. Another exciting discovery is gravity waves. In 2015, scientists detected tiny ripples in space-time caused by two black holes colliding. These waves were predicted by Einstein over 100 years ago. Detecting makes them help us learn about the universe's biggest events, like the star explosions and galaxy mergers. Relativity also shows up in science fiction. Ever watched the movie where astronauts go to space and time passes differently for them than for the people on Earth? Well, that's based on distant planets. That's based on Einstein's work. Even ideas like traveling through wormholes or bending through space to explore distant planets come from relativity. In education, the theory of relativity inspires us to think outside the box. Einstein showed that the universe doesn't always follow common sense. Learning relativity teaches us into assumptions more unknown and look for deeper truths. Alright, so that's all we had for today. We'll see you in the next one. Don't forget to like and subscribe and always stay curious.